going to be doing today is a regressive H&E stain. A regressive, the main thing you need to know about that is if the stain setup has an acid alcohol component to take out some of the stain, then it is going to be a regressive stain setup. So the idea is, with this, is to overstain with the hematoxylin and then take some of that hematoxylin out to make it a little more crisp and bright with some acid alcohol. The reason people do this and believe that this is a great method, and most laboratories, clinical laboratories, actually use the regressive stain, is for the very purpose I just said, is you overstain and then you take some of that out and it leaves a really beautiful chromatin pattern, really crisp edges with very minimal background staining. So that's why they would choose this method. Now, there are some places that use what's called a progressive stain, and we can talk about that a little bit later. The main thing with the progressive stain is it uses a slightly weaker hematoxylin, so you don't have as much background, and it doesn't have the acid alcohol because you're not taking anything out. You're just progressively staining throughout without taking anything out. Starting off, we have the stain set up here. The first thing we need to do is deparaffinize in our stain setup. So we have our slides, and this is a critical step, is to get all the paraffin out. In our laboratory, we use Safe Clear, and that's why I can have this stain set up on the counter. Safe Clear is an aliphatic hydrocarbon or a mixed naphthol, and our first three stations of deparaffinizing are with this Safe Clear. Now I haven't marked xylene here, but it is actually a xylene substitute in these containers. If this had been real xylene, I'd have to do this under the hood. There's something to note about Safe Clear or a mixed naphthol or aliphatic hydrocarbon. Number one, it's safer than xylene, and it's safer than some of the other xylene substitutes, for example, limonene and some of the other ones out there. So you want to be really careful which substitute you're actually purchasing and make double sure that it is the aliphatic hydrocarbon or mixed naphthol that you're choosing. The other thing to note about Safe Clear or the mixed naphthols is they absorb water more quickly. So you have to rotate these solutions more frequently or change them out more frequently because they do pick up water from the atmosphere. Also, these take a little bit longer to deparaffinize than xylene. So, for example, if it was 5 minutes in each one of these, you may want to increase your timing. If it was 5 minutes for each one in xylene, real true xylene, you would want to increase your timing to 6 minutes in each one, or even up to 7 minutes, depending upon what you're doing and the thickness of the sections that you're using. Next thing I have is 200% alcohols. The first alcohol is to get the xylene substitute off the slides, or xylene if that's the case, off of the slides. The second one is to actually make sure that it's completely off, the xylene substitute. Now, anything after xylene has to be 100% alcohol because xylene or xylene substitute can only mix with 100% alcohol. It cannot mix with a more dilute alcohol. After that, we're going to go into 95% alcohol. One change, some stain setups have two. We feel one is enough in our stain setup. We have an 80% alcohol, and then your next step is tap water. That's what we use in our laboratory. Now, some labs like to really control the water and use filtered water or DI water. We find in our laboratory that the tap water is just fine. After this, we're going to go into our hematoxylin. I have filtered our hematoxylin ahead of time because we're using a Harris hematoxylin, which requires filtering just before use every time. You can use a number 4 Wattman large filter paper. In our laboratory, we found just simply paper towels and filtering it through that was just fine and worked fine for us. We have an acid alcohol. We make this up in our own laboratory. 0.3% acid alcohol, and we've marked a bottle. We keep it on hand. Then we do a step that's called bluing, and we can talk more about that later when we are actually doing the stain. For bluing in our laboratory, we use saturated lithium carbonate, and we make it in-house. But you can use ammonia water in a lot of laboratories. Just use simple ammonia water, 0.3% or 0.5% ammonia water, which is ammonium hydroxide in distilled water. The next thing we have is an alcohol step. We use 80%, but you can also use 95%. That's fine. The reason we have this is because Eosin is actually made with 95% alcohol. And so we want to not introduce water into the Eosin. So that's why we have this intermediary step between just before the Eosin. We kind of shake off the excess alcohol, and then we go into our Eosin. After the Eosin, then we start our dehydration, but it's also a differentiation step for the Eosin. So we have 95% alcohol, so we start bringing it to this and to start differentiating it. And then we have some laboratories just have simple 2 changes of 100% alcohol. In our lab, we like 3, but 2 is fine. And then we start back to the xylene. Now I happen to have xylene substitute here because I'm demonstrating this out open on the counter. Another thing I wanted to mention about the xylene substitute is you cannot cover slip with this unless you have a mounting media that's compatible. And even with a mounting media that's compatible, we haven't been really happy with the results. So what we do is, even if we're just holding it in the xylene substitute until we can get to it, we'll do one of 2 things. Either we're going to go from here and go directly under a hood to straight xylene, real pure xylene, or we're going to hold it in our xylene substitute temporarily until we get all our slides together, and we'll give it a quick rinse in 100% alcohol to get this xylene substitute off, and then proceed on to real xylene for cover slipping. I want to first start off by introducing you to the different hematoxylins and what they mean, because I know that some people don't even know what to buy for their laboratory. In our laboratory, we use Harris hematoxylin, and we choose this particular brand. It's from VWR, but in actuality, it's a VWR labeled, but it's originally from Leica Surgipath. But VWR has put their label on it. So you can buy either the Surgipath, Leica Surgipath Harris hematoxylin, or this VWR. It's the same exact thing. Now this particular Harris hematoxylin, why we choose it for our laboratory, because it's very, very strong. And it has no acids or anything added to it other than the hematoxylin, the metal that makes it Harris hematoxylin, and the dye itself, and water. This Harris hematoxylin, we get in our laboratory things that are fixed in Bouin's fixative, and we get things that are fixed in Davidson's fixative for eyes and other things. So sometimes we have to kind of push our hematoxylin to try to get the stain a little bit darker. Sometimes the tissue has been fixed by some of these researchers for months and months and months, and that hematoxylin isn't going to pick up quite as well, and we need to push it a little bit more. So that's why we chose this particular brand, because we know we are able to push it darker. Now, there are other brands of Harris hematoxylin. I believe there's like a Protocol brand and other ones, and you want to watch that. You can get a more consistent stain with them because they've put an acid component in them. When they add that acid component, it gives a more consistent stain that's not going to get overly dark, which could happen in our laboratory. Because of that acid component, it kind of ripens it to an endpoint, and you can leave it in there longer and not have it really, really overly dark. In our lab, we need to push it, so we don't use that type of hematoxylin. But some clinical labs and some other labs may want that consistency and may want to have a little more reassurance. So the thing you're going to look for is on the ingredients and see if any acid has been introduced into the ingredient. Now, Harris hematoxylin used to have mercury as the metal mordant. Now they use ammonium aluminum sulfate. Now, the difference between the different hematoxylins is ammonium aluminum sulfate as the metal mordant, ammonium aluminum sulfite as the metal mordant, In the case of a Weigert's hematoxylin, you would use a ferric chloride, which is iron, as the metal mordant. And that's the big difference between hematoxylins and whether they're progressive, regressive, is that metal mordant, whether an acid has been added to it, or whether it, the dilution of it. And there's other things and other factors that come into play. For example, for the progressive hematoxylin, like the gills 1, gills 2, and some of those that a lot of people like to use for counterstaining for immunohistochemistry, it's not only the metal mordant, but it's also the actual dilution. The difference between gills 1 and gills 2 is one is actually twice as strong as the other. Now, moving right along to the eosins, there's quite a bit to know about the actual eosins. We started off using just a regular eosin. This is Surgipath, and it's actually an eosin Y, even though it doesn't say that here. The eosin Y is great for just a general eosin, but what you want to see, and what we look for in our laboratory, is 3 very distinct shades of the pink, almost to a really reddish fuchsin pink in maybe the blood cells and some of the components of the tissue, to a middle ground, just a nice bright pink, to very, very pale in some of the background areas. You really want to see those distinct colors. If you see those distinct colors, you've got a perfect eosin staining. But you also don't want it to be so bright that it's interfering with your hematoxylin staining. So you've got to find that balance. Now, in this case, we felt that this was a little bit light for us and what we wanted for our researchers and for imaging. It did a really great job, but we wanted to see some things a little bit more brilliant. So we've chosen our laboratory to go on to an eosin with floxine added. The eosin with floxine is definitely going to create that brilliance. Now, we have a couple researchers that feel like that's a little bit too bright for them, and we can differentiate out some of this and leave it in for less time, but we are overall happy with the results. And a lot of it's a matter of taste and what your researchers or your pathologist is interested in seeing and what they want to see. Either one is a good choice. We happen to like the brilliance of the eosin with floxine. Now, there are some other eosins and hematoxylins. There's a whole nice select set kit. Now, this particular kit is a little bit pricey, but it gives you a very good hematoxylin eosin staining, or even a great hematoxylin stain for something like the background or counter stain for immunohistochemistry. This is one that does have an acid component to it and is ripened, and it's not easy to overstain with this, which is nice for immunohistochemistry because you want that background staining or counter stain to be fairly light. And it's got its defining, which would be similar to our acid alcohol, but it's a very weaker solution of this. And then this blue buffer, which actually would be their particular bluing. So it's a nice little kit, and they've got some different eosins. They've actually got an eosin Y, they've got an eosin with floxine, they've got actually a beautiful eosin orange that you might be interested in trying with this Select Tech kit. And it'll give you some really standardized results. For our purposes in our lab, it's just a little bit too expensive for us. But on a smaller scale, if you're not using a lot of reagents, this might be an option for you. Something to note about hematoxylin also, coming back full circle to hematoxylin, hematoxylin is a natural dye. So when you have your pathologists and researchers saying that they want it more consistent and they're pleading with you to have it more consistent, you have to understand the nature. Because it's a natural dye and it ripens like a fine wine, it's ripening and aging over time, you have to know what you're looking for. When we filter it, we want to see, I'm looking at this particular filter and how this hematoxylin filtered, and I'm seeing it's not very ripened. It's really kind of purpley. What I'd ideally like to see if I knew this was fully ripened, so I'm expecting my stain to be kind of on the dark side today because what I'm seeing with my new bottle of hematoxylin not being fully ripened, is I would like to see this more of a little bit of reddish in my filter and see this a dark purple on top. if I see that, then I know, oh, I've got like the perfect hematoxylin. When I see this and I know my stain, I'm expecting that that's going to be a little bit darker. Now, if I were to see when I filter this that it was all kind of this maroon reddish, then I know my hematoxylin has pretty well expired and it's probably not going to pick up and stain very well. So that's some things, just nuances of the stain that you might want to start picking up on. Because it's a natural dye and it ripens over time, sometimes it's a little bit harder to control from day to day what your stain may look like. What you have, even if you don't even touch your stain up, your stain setup and your hematoxylin there other than to filter it, even if you've never used it from Monday except once, what you get on Monday compared to what you're going to get on Friday after it's ripened and had air and light exposure is going to be slightly different. So you have to understand that with your hematoxylins. Also, hematoxylin, I don't recommend using it much beyond, even though sometimes they say a year, but I really try not to use it much beyond 6 or 7 months. And again, just look at your filter, and that'll give you some clues as to what your hematoxylin, what you can expect from your hematoxylin. Now we're going to get started with our regressive Harris hematoxylin H&E staining. We're starting off with our 3 xylene substitutes. This isn't real xylene. If it had been real xylene, you would only need 5 minutes in each of your first stations. Since we have xylene substitute, which is an aliphatic hydrocarbon, I'm able to do this on the counter, and I'm going to actually increase the time to 6 minutes in each station. You may want to test that if you have thicker sections. I have 4 micron sections. You may want to increase it to 7 minutes just to be on the safe side. Okay, 6 minutes is up. I'm going to move to the next station. I'm going to give it some agitation initially, and I'm going to go for another 6 minutes. Okay, 6 minutes is up. I gave it some more agitation. I'm going into my third one, and I recommend 3 changes of this because this is a critical step in this process, and you really want to make sure you're getting that paraffin out. Do not skimp on these steps. Okay, so my 6 minutes is up. I'm going into my 100%. Now the first 100% is going to remove my xylene, or in this case xylene substitute. And the second one is going to make sure that it's removed and start the dehydration process. Now again, xylene or xylene substitute cannot mix with anything but 100% alcohol. So the following, these are critical stations here in making sure that xylene substitute is off, and it has to be 100% alcohol, and it has to be fairly fresh. At least this very first one has to be fresh. So now some people will say 20, 30 seconds. Some people believe it's 2 minutes in here. I believe you do not need more than 20-second rinse in this first alcohol. And we've had excellent results just by doing it for 10 to 20 seconds. That's up. Now I'm going to do another 10 to 20 seconds in this next one. "10 to 20 seconds is up. And I'm going into a 95% alcohol. The 95 is really starting its actual dehydration. Again, all you really need is another, 10, 20, 30 seconds. Now, some people believe strongly that you need this a minute or 2 for each one. I just don't think that's necessary. So I've gotten my time in here completed, and I'm going into my 80% alcohol. Now, you can have 70% alcohol in this because really what you're doing is just, like I said, you're actually hydrating this, not dehydrating. You're actually bringing it to water. And then at the end, you're going to do the opposite effect once you're finished with your staining. And 20 seconds. And I'm going actually to tap water. Now I do like to rinse it a little bit longer in the tap water. I will rinse it for a full minute in the tap water just to get it really saturated with the water and hydrated. So now if you notice, I do not have the water actually right next to the slide. So if you have a full rack of slides, you might choose to have the water off to the side like this. In this case, I can have it here, but I don't have it directly on the tissue itself. I'm going to leave this in here for at least a full minute. While that's rinsing there, I have pre-filtered my hematoxylin, and I'm going to go ahead and get it into this container. And it's good for the rest of the day once it's been filtered, or at least until evening if you have a later shift in the day. You might want to filter it again. And then you would rinse this out and throw this away and rinse this container out and hang it up to dry. I'm just going to move it aside for now. Okay, so we've been in here for a minute in our tap water. I'm going to go ahead and turn it off. And I'm going into my Harris Hematoxylin. I'm going to be in this Harris Hematoxylin for 10 full minutes in our laboratory. This is what we've standardized for general tissue. Although there are certain tissue types that we would lower that timing for in our laboratory for research for best imaging quality. We know that certain tissues pick up the hematoxylin much darker and stronger than others. For example, mouse lung tissue tends to pick up in the alveoli and stuff much, much darker than, say, like a kidney or a liver. For kidney, liver, or brain tissue, we will put it in there for the full 10 minutes, maybe even 12 minutes. For kidney and something like intestine or something like that, this 10 minutes is just fine. You can maybe even go 8 to 10 minutes. If you're doing something like spleen, which picks our lymph nodes, which picks up the hematoxylin very darkly, you might want to take a look at that and maybe only put it in for maybe 5 to 7 minutes. Instead of doing that, since it's a regressive stain, what we opt to do in our laboratory, instead of having those kind of timings all over the map, we have chosen to go ahead and stain it around 10 minutes and then take out that stain with our acid alcohol when we're done with this. So if it's a little bit overstained, we'll take it out just a little longer with the acid alcohol. So we're going to choose to take out what we need with our acid alcohol here to some level of acceptability as a general overall stain. If you're doing this for publication and research, you may want to start thinking about your tissue types and think about something like lymph nodes and spleens and stuff like that that really pick up the hematoxylin darker, and really consider that your timing and how much you differentiate. You can either choose to leave it longer in the hematoxylin and take it out more later on, which is a good option, or you can choose to try to optimize between the two. In our case, I'm going 10 minutes in our Harris Hematoxylin, very strong hematoxylin. Our 10 minutes is almost up. I'm going to go ahead and rinse it in water. That's our next step. I don't want to make a mess, so I'm going to give it that little bit of agitation some more. If you notice, as I switch between solutions, the initial thing, I give it some agitation. As I take it out, I give it some agitation. And I'm going to set this in the water. I like leaving it in the water just until that water is fairly clear. Okay, so the water is clear from my hematoxylin. Now I'm going to go into my acid alcohol. I'm going to kind of get this out of the way and make this closer to the water. Now the acid alcohol works pretty quickly. We use a 0.3% acid alcohol. Some laboratories use a 1% or 0.5%. We feel like that goes a little bit too quickly for our purposes and takes things out too rapidly. We really like this 0.3% acid alcohol. It gives us a little bit of time and maneuverability with how we want to differentiate and for how long. It gives us some extra leeway. So I'm going to have the water still running. And I'm going to give this, in our lab we use 3 quick dips. And I kind of look at it, actually I'm seeing I want to go 4 quick dips. And I put it into the Water. It's very critical that you rinse this acid alcohol out completely. So I will leave it in the water a full 2 minutes. Okay, our 2 minutes is up. The next step we want to do is another critical step. It's the bluing. Now the bluing, some people consider that we use lithium carbonate in our laboratory, but some people think the bluing you need a full minute. We in our laboratory use anywhere from 30 seconds to a minute. It's not that critical. What you really want to see is that color shift as soon as you put in the bluing to a real nice blue jean blue color. And I hold it in here. I think 30 seconds is plenty of time. You can use a minute. And then again, you're going to put this in the water. Now this is critical for the bluing step, that you put it in the water for a full 2 minutes. And the reason is it's actually creating a binding and a chemical change in the water while the water is rinsing. Some laboratories, just so you know, if you didn't have lithium carbonate or you didn't have ammonium hydroxide in water, because you can take a container like this with about 200 or 250 mils of water and put like approximately 3 drops of ammonium hydroxide, or you can make a 0.3% ammonium hydroxide in water, and you can use that for your bluing step. But the other thing you can do is, if you don't have either solution, is you can leave it in actual tap water. It has a bluing component, but you would leave it in the tap water for a good 10 minutes. And it will actually blue very similar to what these solutions do. This is just a more rapid bluing step. The water is binding that reaction. So later on, a year or so later, this hematoxylin is not going to fade. That nuclear staining will not fade later on with this bluing step, and that's the critical component of this, and making sure it's rinsed well and has the reactions that it needs. Okay, so we've been a good full 2 minutes in our water. I'm going to go ahead and go into this alcohol prior to going into Eosin. Let's turn off our water here. The reason I'm going into an alcohol, you can use 80% or 95%. The reason we go into an alcohol prior to Eosin is because Eosin is made in 95% alcohol. And it does create a little bit of a precipitate reaction sometimes when you use water before going into Eosin. You can maybe be able to get away with it, but I don't recommend it. It makes a much nicer Eosin stain. So in our case, we're using 80%, but again, you can use 95%. And all you need is a fairly quick rinse, 20 to 30 seconds. Now I'm going into Eosin. I'm shaking off some of the extra alcohol, and I'm going right into my Eosin. I'm agitating it, which I like to do before everything. Now the Eosin, we're using a really, really bright Eosin with floxine. So our Eosin, we only need to be in there 20 to 30 seconds because it's so bright. If you were to use another just simple Eosin Y, like we had here, you could actually go into the Eosin for a full minute to a minute and a half just to get a little bit more brilliant staining. And then differentiate it out a little bit, and it'll make those color shifts. In our case, this Eosin has its color shifts immediately, and we're just slightly differentiating some of that out. I started off with hydration, and now I'm coming full circle and I'm going dehydration. And at the same time, I'm differentiating the Eosin. So I put it in this 95% alcohol. I put it in here for 20 seconds with some agitation. My 20 seconds is up. Now I'm going into 100% alcohol. Now something I want you to know, it doesn't bother me that this 95% alcohol actually has a lot of Eosin in it. That actually helps with some of the color shifts with it. The way, if you understand the way Eosin works, having that kind of primed with a little bit of Eosin afterwards makes for a beautiful Eosin staining. Now I'm going into my 100% alcohol. Again, it's a little bit differentiating. Some laboratories only need 2. That's fine. You can have just 2. I like to have 3 because I want to have it just a little bit clearer at the end before I get into my xylenes, but 2 is absolutely fine. Okay, again, I've been in here 20 seconds. I'm going into my next 100% alcohol. Another 20 seconds. Okay, that's been 20 seconds. I'm going into my next 100% alcohol. That's 20 seconds. And now at this point, we're fully differentiated the Eosin. We might want to take a look at it under the microscope and see if we need to differentiate it slightly more. Make sure it's not overtaking the hematoxylin because our Eosin is very bright. So I take a quick peek under the microscope to see what my nuclei look like. And I'm seeing that it's a little bit too pink for me. So I'm going to go ahead and leave it and go backtrack it back to the 95% alcohol because it's still just a little pink. Now I can leave it in the 100% alcohol a little bit longer, or I can just backtrack it. The 95 is going to pull it out a little bit more for me, a little bit quicker. I'm going to leave it in there another 20 seconds and then bring it down. That's something I want you to know about the H&E Stain also. It's very forgiving to some level. There's a point where you can overwork it and overdo it on backtracking and stuff like that, but there's a lot of forgiveness for it in backtracking it and redoing some things. Okay, that's good. I've got a little bit of that, you pulled some of that Eosin out a little bit so I can get that nice color shift, not just an overall pink that I was seeing, and a little bit of interference with the hematoxylin. Perfect. I'm seeing, for my eye, because I'm used to doing this stain, I see that this is what I really want. Let me show you a little bit. I don't know if you can pick this up on the thing, but I'm seeing some nice darker areas. I'm seeing some bright fuchsia areas, and I'm seeing a really kind of light overall pink. So if you kind of see that even macroscopically, you get an idea that your stain is right. You see those color shifts macroscopically, and you see some darker and lighter areas macroscopically. And then when you look under the microscope, you're going to see some, your fully confirm what you're macroscopically seeing. Now I'm going into my xylene substitute. Now I can either go into the xylene substitute from this 100% and then hold it there while I do some other staining, some other things around the lab, or I can directly go into xylene under my hood, which is what I normally do. Because we have an automated stainer, sometimes we're busy around the lab and it ends in this xylene substitute for us. If it ends in our xylene substitute, we have to rinse it off a little bit with the 100% alcohol and then go into real xylene for cover slipping. That's what we do here because we don't like the results of the mounted media that's compatible with the xylene substitute. We prefer actual xylene and a xylene-based mountant. What I'm going to do now is I'm just going to simply go under my hood, give it one more quick rinse in 100% alcohol, and put it right in xylene and hold it and have it ready for cover slipping. Now we can hold for very long, you can hold overnight for a long time in my xylene or xylene substitute. It just depends. So to repeat what I'm saying is, if you use xylene substitute, you need to rinse it off. It's not good for cover slipping. And how you rinse it off is you do a couple quick dips in 100% alcohol and then do a holding in real xylene under the hood. If you don't want to use the xylene substitute, you want to go directly to xylene, you can certainly do that. In the interest of this demonstration, I wanted to talk about that a little bit. After this 100% alcohol, I would go under my hood and I would go directly into xylene and have it hold there. I would do 2 changes of xylene, and the last one would be holding for me to actually cover slip. So I'm going to give one more quick dip in my last 100% alcohol here because I know that this one would have rinsed off xylene substitute and I don't want that on my slides. But I'm going to give one quick dip in this fresh 100% alcohol, put it into my xylene for 1 minute, and then I would hold it for however long I wanted to or needed to in the next xylene if that's not critical. very few stains is at a critical step, how long you hold it in the xylene. In this case, I had a trichrome there waiting that we had did earlier. So I'm going to go ahead and add these trichrome stains to my rack so I can cover slip them all together later. And I'll leave that holding here until I'm ready for cover slipping and I finish some other stains. It'll just stay there, it won't hurt anything. And that's it. That's the H&E Stain.